Hello, I'm Clement Nate, and this is a short presentation on containerization. And so it's going to be in two parts. One part being the theoretical part, showing all the theory about containers, and the other part being a demo for containers or how they actually work. So the outline is going to be where we are going to define the terms for the first part, and in the second part we're going to look at the demo. So what is containerization? Containerization is an OS level virtualization method used to deploy and run distributed applications. So applications mostly in the time past were written as monolith applications. That's just saying that everything was written as one and put on a server. But this time you're looking at breaking the application into separate parts, where each part is going into a container, and that way you're able to work well in development. So with the traditional methods, code is developed in a specific computing environment, and then it's supposed to be transferred to another machine. So there are instances where people develop on a Linux machine, and they're supposed to take it to their Windows friends or people on Windows to actually work with it, but they actually end up getting errors and problems just because of some environment settings. So containers will just help you to bundle up all your code such that it contains all the variables and all the runtime instances that you need to actually get your code running. So containers then will be defined as a standard unit of software that packages up code and all its dependencies together so that it's able to run everywhere. So Docker, Kubernetes, Istio, Mesos have been a few companies that have come up with container technologies that we use or that are quite popular nowadays. Where are containers used? So for developers, they just use it to mitigate the issue of it works on my machine and it doesn't work on yours. So once it's bundled, it's an image is created from the container, and then you're able to just send the image over to any other person, or the other person is able to pull the image and use the image as it comes, and there's no environment configuration needed in there. Operators, on the other hand, use containers to actually efficiently use your machine in terms of compute density, so you're able to get better compute density with containers. So cloud providers would use things like load balancing to balance the load and traffic that's coming towards their service so that they get the best performance out of it. Enterprises, on the other hand, would use containers to ship features quickly, because their monolith applications will now be broken down into microservices or smaller applications. So new features can be added, and as they are added as containers, so they just link up to the other containers and you get one big giant application running. Okay, so why do we need containers? I'm just going to talk about a few of the reasons that are listed here, but one of them is that they are lightweight, very lightweight, so they just take what your application needs to run and bundles it up. The next is for faster onboarding. So when you have new developers on your team and you want to introduce them or give them the code, usually it takes time to set up your environment to start working, but containers help you to get that done in no time, in very quick time. And security is also high because you're able to get this level of encapsulation around your applications that help it to be very secure. So the history of software development has been very rough. So it started out with just traditional deployment on one system, and then we moved on to virtualized deployments in different VMs, and then containers came about, and then we were able to make containers, but Kubernetes came in to solve the problem of the container scaling, because containers couldn't really just scale as well. That's in Docker. So Kubernetes works in conjunction with Docker to make this scaling problem a thing of the past. So this is how containers work. So there's an infrastructure, there's a host operation system, and then you should have like Docker running, and then you have different apps running in different containers, and that is basically how containers work. So the problem of VMs versus containers. So someone would tell me that if a container is actually just literally running an app in isolation, then why don't I use a VM? So this is the structure of the VM versus a container. So a VM actually has a guest operating system on it, so it's heavier than a container. A container just has a an engine, and then on the engine are built the apps. But for every virtual machine you build a copy of the operating system, and that makes it quite heavy and quite difficult to deal with. And so you have Docker, and Docker is simply a container system. So some Docker components are the Docker build, Docker pull, Docker run, and so you have the Docker host, which will have the containers and then the images. So images and the containers are not persistent, but when you make a volume, you're able to get your images and your containers to have a certain level of persistence, so that's to say that they don't store data. So when you have a volume, you start to store data with that. Kubernetes, on the other hand, which we'll see in the second part of the tutorial, has a specific job, and this job is to make sure containerized applications are managed well. So Kubernetes has pods, and in pods you have containers. So pods run containers and volumes, and then you have a number of pods which actually end up making a node. So that is the end of the Kubernetes pod, which has just the pod with a shared IP address, and then you end up with a node, which is a cluster of all the ports coming together, and all these ports are linked together and running on a network within the node, so that you're able to communicate together via RPC. So this is basically how Docker and containers work. In the next part of the tutorial, we're going to go more in depth and see how we could practically use Docker and Kubernetes. Thank you for watching, and you can find the second part of the video, the link to the second part of the video, in the description.